Alright, sorry Ethan, I missed the first two, but I just remembered to turn the video on. So, does everybody agree that you need a 2/3 to make U work right here? Everybody agree? Which puts 3/2 on the front. So then, we know that we're really just integrating cosine of U du. So what's cosine become when you integrate it? Sine. Let me move my 3/2 down. So 3/2 sine of U is what I get from integrating that. Now, in the first fundamental theorem of calculus, you have, again, two choices. I can put the x information back in, and if I do, I integrate that from 0 to pi. Or I can change the values by first just calculating up that if U is equal to 2/3 x minus 3, then U would be what if you plug 0 in? 0. And U would be equal to 2 times pi over 2 over 3. I forgot the 3. 2/3 times pi over 2, and don't the 2's cancel out, making it pi over 3. So I have a choice. I can substitute the x stuff back in, or I can do this math over here to the side and convert these x's to u's, and then I would be able to integrate it a little bit less cumbersome because I've already done the math for the fractions on the inside. Where? Oh, thank you. I left the 2 off. Yes, thank you. So it's just a matter of, I think doing this math on this one to the side is a lot better because now I'm going straight to plugging in what I need. Where if I did the other problem that I set up over there to the right, I'd have to still do that fraction work inside of trig, where I've done the fraction work over here to the side, and all I'm having to do is calculate up really the trig. So sine at pi over 3 is the square root of 3 over 2, because it's the third line up. And sine at 0 is 0. So the answer to this question is 3 squares of 3 over 4. Because the other part's gone away. 0 times anything drops off. So this is 3 square roots of 3 over 4. So in my personal opinion, some questions are easier to leave the U in there and do some of that scratch work to the side by calculating up what your values of U would be and then plugging U's in instead of X numbers. Now, not all of them are that way, but some of them are. Now, my next example, this problem, let's see which way we think it might be easier to work it also. We're still doing chain rule, so we're still going to start it out with chain rule every time. And then we're going to look at, do we want to leave it U or do we want to go all the way back to X? The answer to this question also is still finding the same thing, but the directions on here are a little bit different. It says find the area. Isn't finding the area always integrate? Okay. So just because I changed directions doesn't tell me I'm doing something different. It just means they're trying the perspective of finding the integration sums up the area. Yep, every time. So in this problem, yeah, you can. All right, we're really going to integrate U to the 1/3. Okay, but before we do that, X plus 1 is U. What's the derivative of that? That's right. I got an extra piece. That's a problem. This is that substitution that's not chain rule. So we might want to move that over. 1/3. So this part would become U to the 1/3. This X over here we got to solve for. Because x is equal to u minus 1. So we're going to take out the x and put in u minus 1 for it. We took out the x plus 1 because that's equal to u and made this. Now it's du because I can substitute that.
What is that?
Because dx is equal to 1 dx is equal to 1 du. I have 1 dx, so I take out dx and put in du. I'm not putting any numbers on it right now because these are not u numbers, are they?
So you plug.
I am doing that other kind of substitution.
I know it's like plug into the other one.
So in this one, no, you don't have to. We know what this is equal to. We could go straight there.
So that, okay, is that it? Okay.
Okay, but I could have put in u minus 1 for this x, plus 1 cancels out and goes back to u. I could do it with both of them, but considering I have a formula that says u equals, I just took and put that in as u, like we do for regular chain rule. Alright, so now I need to distribute that. So it'll be u to the 4/3 minus u to the 1/3 du. So this is that other kind of substitution method. Now once I do that substitution method, then I add 1 to the power, which is going to become 7/3 with a 3/7 in front. Add 1 to the power, it's going to be 4/3 with a 3/4 in front. Would everybody agree with that? So now my question is, do you want to go back and put all what x was in both of these holes, or do you want to convert 0 and 7 to u numbers? This is what you'd use to convert them to u. U is equal to each x number plus 1.
Let's do that.
Okay, so that's the idea. U is equal to 0 plus 1 is 1, and u is equal to 7 plus 1, which is 8. It would be a whole lot easier in this question if we don't put back the x information and keep it u, because these are cube roots. And I don't think we can cube root some numbers as easily as others. So to me, doing this math outside gives me two perfectly cube rootable numbers to plug in, because there's a cube root to 8 and there's a cube root to 1. So that's why I want to leave it. All right, so let's talk about plugging in 8 to the 7/3 minus 3/4, 1 to the 4th, no, 8, excuse me, to the 4/3 minus putting in the 1. All right. You don't. Let's talk about that 8 to the 7/3. That's the same thing as the cube root of 8 to the 7th power. So the cube root of 8 is 2. 2 to the 7th. 2 times 2 is 4 times 2 is 8. 2 times 8 is 16, 32, 64, 128. So 3/7 times 128 minus. Over here, the 8 to the 4/3 means the cube root of 8 to the 4th power. So 2 to the 4th is 16. So that's 3/4 times 16. Over here, 1 to any power is 1. So that makes the math easy, because it's just 3/7 minus 3/4. And it doesn't matter which way I did this, the math is nasty at the end because it's all fractions. So at that point, I could say 4 goes into 16 4 times. I don't know how much that's going to help, but we'll see. Man, this is nasty. Hey, let me show you a math trick. There's a math trick to this, but I don't need to multiply it out, but I need to distribute that negative over there. Okay, so I've got 3/7 times 128. I also need to add negative 3/7 to that. You with me so far? I've got this 3 times 4 here that's going to be minus 12, which came out a whole number. And I got plus 3/4 over here on the end. So I got some definite issues here. Did you know you really don't have to multiply those first two together in order to get this math to work? This has a 3/7 and this has a 3/7.
Wait, did you just,
And I just rearranged the problem. What's what I did?
so the 12 that was in this was up there.
Yeah, because I distributed this negative so I could rearrange the problem, put things in the order I wanted them. I saw two of them had a 3/7 on it, so I brought them up to the front because sometimes you don't need a calculator to do this. I thought this was a good trick to show y'all because on the non-calculator part, who'd want to multiply 3 times 128 and try to figure out how to reduce that, y'all? Nobody. But if you have the same fraction on both of them, you can take the fraction out using the undistributive property and subtract these two, and then you can multiply together later. Now at that point, you need to decide, do you want to put these two together by force, because we could, or do you want to go ahead and multiply this out and get a common denominator for the whole problem? Personally, I think this would be real easy to put together, so that you end up with two fractions at the end to get the common denominator with. The less fractions you have, the better. But does everybody see how I did this undistributive thing so I could do that without having to work out that big number first? Okay. So this is going to come out negative 45 over 4 because that's 48 over 4. Everybody agree? 12 is 48 over 4. Over here I got to multiply this out, so 173. And then I just get a common denominator. Because that's supposed to be an 8. 3 times 7 is 21, carry a 1. 2 times 3 is 6, plus 2 is 8, and 3 times 1 is 3. So then I'd get a common denominator. I'd multiply this one by 4 and this one by 7. 1, 2, carry a 3, 15 over 28, minus 5, carry a 3, 31 over 28. And whatever that subtracts to give will be my answer, if I didn't make any math errors along the way. That looks like that would reduce. No, it's supposed to be an O. It's a really bad O, though. So 1206 over 28 looks like it reduced by 2 at least. So that'd be 403 over 14. I don't think 403 reduces by anything.
1524.
1524, yeah.
Oh, thank you. See, I told y'all I might have made a math error. How much is this right here? 1524. Oh, I guess I just forgot to make my mark through my 4 because I said it. All right, so then that makes it how much when you subtract it? 12 something. 1209. All right, and that probably don't reduce, does it? Because the top's divisible by 3. It won't now because it's got a 9 on the end.
It was 6 or something.
That was the other one before I made the math error. Yeah. That's before I went back and figured out I wrote this number wrong. It's okay. Alright, so calculator can be very helpful, can it? Because that's a lot of math.
I couldn't do that in my head. It took me 5 minutes to do it on paper.
Yeah, but you know what? On the non-calculated part, you might have to multiply some numbers together. They may not be quite this big, but you might have to multiply some numbers together. All right. Now, the last thing I want to show y'all today is the even-odd rules. I had another problem that was trig, but it's not really all that important to do that one. I mean, it's the same idea. It's just it had two things that needed to be integrated each individually, and we can do that. It's not a big deal.
I feel like we learned something new, but it just wasn't the same.
It is the same thing, but this isn't. So this is a little different. We talked about this, but we've never wrote it in our notes. Even odd rules. Even odd rules are based on the shape of the graph being symmetrical. Even functions are symmetrical about the y-axis. And odd functions are symmetrical about the origin. This goes back to what we studied in pre-calc. Does it look like I flipped it over the y-axis, or does it look like I rotated it 180 degrees? Now, pretty much, this is all based off of the looks of the original problem in your integration. So if I'm integrating from -2 to +2, first of all, those two numbers need to be opposites of each other for this to work. And we're looking at 3x squared minus 12, which happens to be a quadratic. And some quadratics are not even functions, some are. If your quadratic goes down here to -12 and opens up, because there's no middle term, half of it's on one side and half of it's on the other side. Does everybody see that? Because the numbers are the same. So what they say to do instead is to find the area of one side. So like find the area of this side, because putting zeros in formulas is a whole lot easier, right? So they changed the problem to double from 0 to 2. Because if you do it from 0 to 2, you could double it and have the answer and not have to do the negative side. And why that's important is because 0 is a real easy number to plug in and do math with. So now, if I integrate this problem, that's going to become x cubed minus 12x. Everybody agree? From 0 to 2. And then when I get done, I'm going to double the answer. The doubling part doesn't happen until after you're finished with the fundamental theorem of calculus. So 2 cubed minus 12 times 2 minus, both of those are going to be 0. That's why you want to do it this way. So if you have an even function, half the graph's on one side and half the graph's on the other side, and these two numbers are opposites of each other, you can just do it from 0 to the top and then double your answer. So that's 8 minus 24, which is -16, and times 2 is -32. Did I do that math right?
Yeah. It is 8 minus 24.
Well, I sure didn't do it right on my paper, because I wrote a square down for a cube.
I'll put everything on your paper is usually wrong, then you fix it.
I copied this down wrong with the wrong number. I don't know why I did, but I did. I plugged an 8 in for a 2. 8 minus 24, which is -16, which is -32.
Oh, when it's out, or going back to the first, or what you did right before this, when you're talking about finding the area,
Mhm.
you have a really nice fraction. Do we have to put units squared on it? Is that correct? Or is it-
Technically, yes and no. If it was a word problem, I'd put some units on it. They don't always do it when it's just an integration problem, and I don't think they take off of that. But when we start going some AP questions, if I see that, we might talk about that more in depth. But I don't think so. Now, if you're using geometry formulas to find it, like we did on our test, yes, because you were doing geometry formulas. But when you're doing integration, we know it's area. All right, let's look at an odd one. Now, how I know this function is odd, and I made the easiest odd function I could. Oh, because it's quadratic.
Cubic's odd.
Oh.
So one of the things you have,
Whatever the power is.
well, you got to be careful of that, because if the quadratic doesn't touch the y-axis at the origin, vertex, it wouldn't have been. So you just need to graph it and look at it. Okay?
For these to work, you have to be perfectly over the y-axis.
Right, you've got to be the same amount on each side. So these two numbers need to be opposites. You need to graph it and see that half of it's on each side of the y-axis or half of it's on each side of the origin. This graph itself, x cubed, is this function with that inflection point in the middle, remember? That's why we can find the area so easily. Now, this is not drawn really to graphing shape here. So unfortunately, it's probably not going to, I mean, I shaded the wrong spot up here. Should be shading the other way. Alright, so you should shade from the function down to the x-axis or up to the x-axis, depending on if you're above or below. Not to the y-axis, because I'm not doing y's, I'm doing x's, so it should be to the x-axis. Now, what do you notice here is they should be the same amount of area, right? So the answer is 0. Well, this has negative area, and this has positive area, and negative and a positive cancel, right? Say what?
Are all like this?
Only if it is a function where half the graph is on each side of the origin. It has to touch the...
They were both on a positive and a negative plane.
And because it went through the origin, that was the inflection point that cut the graph in half. That's what made it have half above and half below.
So what I'm hearing is that the bottom half of the graph had all this negative area, and the top half of the graph had all this positive area, and they had the same amount, so they just, when they came together, they made no area.
That's right. That's what
Really area.
it is. Because negative area, and I know it doesn't make sense to talk about negative area, but that's a thing just like velocity is negative. Negative area means it's below the axis. It's location.
Overall, it's 0 location.
And so therefore it cancels each other out.
The graph has 0 location and no area.
No area at all.
Oh, it still has area.
0 is a number, y'all. Y'all seem to think 0 is not a number.
Oh, I do have written in my notes one time when you said 0 ain't nothing, and I was like, that's deep. It was
Yep.
like when you were saying, who is you, the other day.
Uh-huh. Really deep. Alright. So, there's not a lot in here on this because the majority of us was learning the indefinites. So, on page 297, your assignment starts with number 56, and you are going to work through... No, but just not very a whole lot. 76, and then you're going to skip down and do number 82 because it's in the even odd rule. So you either got an even one or you got an odd one. You got to figure out which one it is because I only gave you one of them. Now, when you start off with 56 to 76, there are actually 3 sets of directions there. The first one is just outright do what it says. The second one says area, so you're just going to outright do what it says. But on the third set, it says use a graphing utility to do it. And that means use the integration button on your calculator.
So it's easier to use press it in the button.
Yeah, 72 through 76 is use the graphing utility to evaluate, so you're using the button on the calculator for integration. Okay? All right, any questions?
That's Primo and Jelly.
All right. So I know this took longer than I thought it would, y'all, but y'all had quite a few questions on the homework. So that's going to affect us a little bit on what I had planned for tomorrow, but that's okay. Let's see if I have a worksheet for tomorrow.
I don't mind worksheets anymore, as long as they're on paper.
No. You guys keep your head above water now. I can't let you drag you up.
Wow, I do. So tomorrow, instead of having a quiz, since Ethan wasn't here today, we'll check this homework and we'll do a worksheet. And our quiz will be Monday.
Kelly, can we say thanks?
There you go.